Hello everybody. So we're about to start chapter 2. So this will be the first lesson of chapter 2, but before we begin, I wanted to go ahead and review some of the rules or ideas behind exponents. Not necessarily the rules of exponents, but some of the concepts related to exponents. For example, x to the 0 power. Anything to the 0 power is a 1. That is an Algebra 2 topic that we cover. Another concept about exponents is that when you have let's say a negative exponent, like x to the negative 1, it means 1 over x. I don't know if you recall, but anytime there's a negative on an exponent that has nothing to do with negatives, the negative exponent basically tells you to reciprocate the term. So the term goes to the denominator, or if it's in the denominator, it goes to the numerator. Basically, in layman's terms, it just flips. It causes that term to flip. So x to the negative 1 would be 1 over x. And then if we have a rational exponent, rational by that I mean fraction, such as x to the 1/2 power, that means, has nothing to do with fractions. The denominator is the root of the term. So this is x to the first power inside the square root. So this would actually translate into the square root of x. So let's put some numbers in here so we can make this at least try to make more sense out of it. For example, if I have 7 to the 0 power, well, that's a 1. And that would be your result. If I have anything, I can have 2/3 to the 0 power, and that would be 1. Yes. Anything to the 0 power is a 1. Okay, that's one concept. Next concept about the negative exponents. If I have something like 9 to the negative 1 power, what that means is to reciprocate the 9, so you get 1 over 9, and that would be your result. If I have something like 8 to the negative 2 power, that means take the 8, reciprocate it, so it becomes 1 over 8 squared. Okay, so the square is still there, but now you've flipped the 8, so it's now 1 over 8 squared, which would be 1 over 64. Okay, this would be there you go. Then if we have a fraction already, such as, let's say, 2/3 to the negative 3 power, well, the negative exponent tells you to flip the number, so you're going to flip the 2 and the 3, so they're going to reciprocate. So it's going to be 3 over 2 to the 3rd power, and now you do 3 times 3 times 3, which is 27, and then on the denominator 2 times 2 times 2, which is 8, and that's what that would be. All right, let's go to the next thing. If you have let's put some numbers here. Let's say you have something like 81 to the 1/2 power. Remember, the fraction has nothing to do with fractions. It really means, what you're seeing there is you're saying it's 81 to the 1st power, like this, and then the denominator there is the root. So that means it's the square root, like that. So it's 81 to the 1st power inside the square root. Now we really don't put the square, so the little 2 there, it's understood to be a square root. And we don't put the 1 there, it's understood that anything to the 1st power is the same thing. So it's really just the square root of 81, which of course that equals to 9. All right, let's do another one here. So let's say we have 8 to the 2/3 power. What that means is you're going to go 8 to the 2nd power, so 8 squared, and you're going to have the cube root of that. So the denominator is the root type. So it's 8 squared inside the cube root. So now we're going to go ahead and work this out. So we really got the cube root of 64, and cube root means, okay, what you're seeing there is a cube. What is its root? What times what times what times itself 3 times. What number times itself 3 times is 64, and that number is 4, because 4 times 4 is 16, and then 16 times 4 is 64. So the cube root of 64 is 4. So when you see 8 to the 2/3 power, it's really 8 squared inside the cube root. All right. So that's a review of some of the exponent things. So now let's turn that into functions here. Again, I'm going to try to do this a little quick. Remember, you can always pause, rewind, and replay the video, take down some notes as needed, okay? And then we'll discuss it in class tomorrow. Okay, so we're going to go ahead and analyze the function f of x equals 1/2 x to the 4th power. Well, what I want to share here is that the A, B, and C, right here, A, B, and C, the first examples are examples of monomials. They are single terms, like you don't have like x squared plus 3x plus 5. That would be a trinomial. This one is just a monomial. It's got one term, one term, one term. The good thing about those is that we can quickly, based on the exponent here, these are power functions. It's like x to the 4th power, x to the 7th power, x to the 6th power. The good thing is that they're very easy to analyze. See, when you have a parabola, x squared, the parabola goes like this, right? It's a U shape, goes like that. Well, if you have x to the 4th power, it goes like that too. X to the 6th power, it goes like that too. X to the 8th power, goes like that. It just goes at a faster rate. So like x squared might go a little this way, x to the 4th might go this way, x to the 6th, x to the 8th. So it's just stretched out a little more, think of it that way. But all even functions, if the highest degree is even, it's gonna behave, the end behavior is gonna be just like the parabola that's gonna go this way. If it's a negative x to the 4th, then it would have gone down this way. All right, and the same thing now for the odd numbers. For odd numbers, see, the basic cubic function goes like this. Okay, one goes up, one goes down. In the first quadrant, it increases. In the third quadrant, it decreases. So it's like a little snake figure. All right, well, that's pretty much what we're gonna talk about in here. For this term, you just have to remember two basic things. Number one, if you have f of x equals x squared, in other words, it's an even function, well, it's gonna go like this, okay? And the second thing you have to remember is that, the second thing, if you have a function that, like x cubed, that's one of the most basic ones, then it's gonna go like this, okay? So the end behavior for even numbered exponents is gonna go up and up, unless there's a reflection, unless there's a little negative in the front, which way it's gonna flip and go down and down. And for the odd numbered exponents, it's gonna go up on the right side and down on the left side. Or in other words, on the left side down and on the right side up. But if there's a negative in the front, it flips over and goes the other way. So that's what we're gonna talk about here. When it says to analyze the given function, they're gonna ask you all sorts of stuff. We could ask you about the domain and range. We could ask you about the end behavior. We could ask you about the y-intercept. We could ask you anything, but really for this particular section, I know that you guys are gonna depend a lot on the graphing calculator or Desmos. So I went ahead and graphed some of these. Here's 1/2 x to the 4th power. See how that exponent is even and the end behavior goes up over here and the end behavior goes up over here. And of course it contains the 0, 0 is your x-intercept and your y-intercept. You can see that the limit of f of x as x goes to negative infinity is infinity, and as x goes to positive infinity, it's also infinity. That's because the exponent is even. That is why. Now, if we go over here and we look at an odd number, this was the second example, negative x to the 7th. See, it's an odd numbered exponent. You can see there's an odd number right there. So normally it would be going up in the first quadrant and down in the third quadrant, so it'd be going like this and like this. That's what it would be. But see that negative in the front right there? That negative in the front is telling you that you're gonna flip. So in the first quadrant, it'll flip down, and the third quadrant is gonna flip up, and that's why you see what you see there. So you can see that the limit of f of x as x goes to negative infinity is infinity. The limit of f of x as x goes to positive infinity is negative infinity. So we're not doing anything new. This is the same thing we did in chapter 1, but now we're getting specifically power functions right now. And the main thing to understand is even functions are gonna go up and up just like the parabola, and odd functions are gonna go up and down, or actually, well, up and down and up on the basic one, and then if it flips, like in this case, it'll go the other way. But that's pretty much it. If we look at the third graph, here's another one, negative 3x to the 6th power. Well, it's an even function, so it would have gone up and up, but because of the negative, it flips downward. So those are my first three examples here for these. Again, we could ask you any sorts of things. For example, on the first one, you saw that it was a kind of like a U, like a slimmer type of U, but it really, if I ask you to give me the domain, you'll say the domain is from negative infinity to positive infinity. If I ask you for the range, well, the range is from 0 to infinity. Remember that the domain is from left to right, the range is from the bottom up. If I ask you for the end behavior, you would say the limit of f of x as x goes to negative infinity, as the x values go more and more to the left, the function goes further and further up to infinity. And the limit of f of x as x goes to positive infinity, as you go to the right side, the function also goes to positive infinity. So that's your end behavior. If I ask you to find the x-intercept, you're going to say the x-intercept is 0, 0. The y-intercept is also at 0, 0. So I could ask you all sorts of things about this one. Just be prepared in class to answer. And remember that you can always, again, you can always graph it and see for yourself. So as long as you know how to answer these things, like when I ask you, what is the end behavior of this function right here on B? You say, oh, the end behavior, that's the one where you look at the right end and the left hand. But first we start with the left side. So as you start to the left side, you go this way. As the limit of f of x, as x values go to negative infinity, as you go further and further to the left, as you go further and further to the left, the function goes further and further up. As you go further and further to the right, the function, the y values go further and further down. So that is what you're going to say here. As we go further to the left, the function values, the y values, go further and further up. And the limit of f of x, as x goes to positive infinity, is negative infinity. So be able to answer those things. And again, you can use your graphing calculator for these. So that's going to help a lot. All right, let's go to the next thing. I didn't do the